Hi, 8th grade. I wanted to give you some tips on how to write your velocity lab. These things will be useful for answering questions 3 through 6, as well as making sure that your data table and graph are detailed and have everything that you need them to. So first thing for your data table, when you put your data table into Excel, I suggest using the exact same setup as what they have in your actual lab handout. That way you will have, you'll have it set up by the release point, you will have 3 different trials, and you'll have a place for the average. So make sure just to copy the setup in your lab packet. Another thing that I want to point out is that in your headers, so trial 1, trial 2, trial 3, and average, each of those should be actually say trial 1 meters per second, trial 2 meters per second, because since you just have numbers below that, something like 1.4, and you're not including the meters per second there, you need to have it somewhere. So right there would be the appropriate place to have that. That's just a reminder because you always want to have your units. That's an important part of any data table or graph. So for a graph, if you're trying to decide what type of graph to use, I'm just going to kind of give you a little background on what each type of graph would be used for. If we are making a line graph, okay, so some kind of line graph here, we're going to usually have time and then distance, so meters or seconds or something like that. We did meters per second, that works. So what you're showing with a line graph is usually the passage of time, right? You're recording things as they occur. As time passes, here's how distance changes, right? Something like that. If you're going to make a bar graph, you're going to have, here's a bar, here could be a second bar. A bar graph is more for comparisons of data, right? This is what we found here. We found X, we found X amount of whatever it is that we're measuring, right? This is where our label and unit would go. We found, in this trial, we found this amount of whatever, speed. So a bar graph allows you to do a nice comparison of a couple different data sets, right? A couple different measurements. Whereas a line graph, you can still do a comparison. You might still have, 2 different lines, but it's all about the passage of time or as something progresses. So that should help you choose which graph to be using. Just a couple things about your title. Your title should be very descriptive. So your title should not just be velocity lab or speed of ball rolling on floor from the speed lab. That's better, right? But what we should have is really, if you have a fire that destroys all of your lab reports but leaves just your graphs behind, right? That would be a crazy fire. You want somebody to be able to pick up those graphs and tell exactly what you did in your lab just by the data and the title and the labels and units and all of that stuff just in the graph should give them a pretty good idea of what the experiment was. So if we're going back to that speed lab, a really good title would be, for ball rolling on the floor, would be something like speed of a tennis ball rolling down a carpeted hallway, or speed of a tennis ball rolling 1 meter down a carpeted hallway, something like that, something very descriptive. So for this lab, for the velocity lab, we want to be talking about release points and a cart and the velocity, and all of those different aspects should be included in your title. Okay, so descriptive and detailed. So don't forget that we also need labels and units. So these are different in that the label is what you're measuring. And the unit is how you measured it. So did you measure it in meters? Did you measure it in centimeters? Did you measure it in miles? So these are 2 different things, but each axis, the X and the Y, should both have labels and units. Obviously, if your X-axis is trial or something like that, you're not going to have a unit really, but you will still label your data so that it's trial 1, trial 2, and that's essentially what your unit would be. So now to get down to these questions. even if questions 3 through 6 don't say explain, you know that as an 8th grader, our goal is always to explain. So make sure that you include lots and lots of detail, and make sure that you fully explain, describe, and play that why game that we were talking about. Make sure that, if you have a statement, ask yourself why that statement is true. Once you do that a couple times, why it's true, how that happens, do that a couple times, and that one statement becomes 2, 3, 4, 5 sentences, and you have a paragraph, and that's exactly what we're looking for. So each of these should be a short paragraph. So question number 3 is specifically asking you what happens to the velocity of the car as you release it from higher points. Why is this? So we all found that as we released it from 40, then 70, then 100, the cart got faster. It got faster and faster. The velocity went up. So obviously you're going to state the velocity got faster. But then we need to explain, why is this occurring? So I gave you some other questions right here. What is it about releasing it from a higher point? Why does that matter? What vocabulary can we use? We've been, in physics for a little bit now. We've talked about speed. We've talked about velocity and acceleration. Can you talk about any of those words here that depend on time, and the more time we give something, the more it can do of something else. So just think about, all the terms that we've been studying. And then also another question, we haven't talked about forces yet, but what force is causing the cart to move, right? So if you think about all these things in conjunction, right, the vocabulary that we're learning in class, but also a specific force that would be causing the cart to move in the first place, now we're starting to see that by releasing it from, I'm going to set up kind of here's my little cart. Well, look at that, and it's heading down the track. Why, when we release it from here rather than over here, why does it go faster, right? Why is this faster? What is it about releasing it from a higher point, giving it a longer distance? What's going on there? Tell me all about that. Number 4 is saying, what slows the car? If the car was to continue on the track forever, what would be slowing the car down? So imagine if you kept the track exactly like it is now. You do nothing to the track except for make it longer, right? You don't make it higher, you don't increase the angle, you don't, do anything to it. It's just a longer track. What is the force that could be slowing down the car? Think about your car as you drive, or your bike, or, if you have 2 objects that you're, sliding, right? What force is slowing things down? There's a couple options here, right? There are at least 2 options that come to mind that you could discuss. And they're both related, but they're 2 different forces that are slowing down the car. So think about that, like what slows things down as they move. Okay. Some of you were asking me in the lab about the setup and trying to avoid one of these forces, and should you do X or Y, and we had a conversation about that. So if that was you, think about that. Number 5 is saying, how could you improve your car to make it roll faster? Explain why this improves its speed. So again, it asks you to explain not just what you would do, but why this is going to make it go faster. So what things could you do to the car specifically, how it is built or how it is shaped, that could help it go faster? So not just to the track, right? We're not asking about, okay, change the track to make this happen or that happen to make it go faster. The car specifically, how it's built or how it is shaped, or if you want to add some kind of component to it, or you want to do something to the wheels or to the axles or to whatever, right? Think about what you could change on the car. Now that obviously does not mean adding an engine. Keeping the cart essentially the same little green cart that we had, what could you do to it to make that cart go faster, right? Obviously we're not talking about turning it into a, Ferrari or something. Number 6 is saying describe one way you could change the ramp to make the car go faster without changing the release point. Explain why this would help. So this is now saying, okay, in question 5, we're specifically talking about the car. Now we're talking in question 6 specifically about the ramp. So we're not talking about the release point or the length of the ramp. What could you do to the ramp to make the car go faster? So think about what you said in question 3 and why the car is going faster from the 100 centimeter release point than from the 70 or the 40 centimeter release point. What are we allowing to happen at the 100 centimeter release point that doesn't happen as much from the 70 or 40? And how could we make that occur more? How could we speed up this process? What is allowed to happen and what aspect of the ramp setup could we exaggerate, right? Could we make bigger? So what we're not talking about is going from a ramp that looks like this to a ramp that looks like that. See how, if x here equals, 100 centimeters, and now we're talking about the ramp being 200, I know that doesn't look like 200 centimeters, but twice as long, right? We're not talking about making the ramp longer. That is not the answer. That, of course, would. If we released it from rather than 40 or 70 or 100, if we released it from 200 centimeters or 400 centimeters, yes, it's going to get faster and faster. But taking the ramp that you have right now, how could you make the car go down that ramp faster? What part of the ramp, what part of the setup, right? I like that word there. What part of the ramp's setup could you change to make it go faster? I hope this was helpful in kind of showing you how you should be thinking about these questions. Remember, we should end up with 4 paragraphs. 4 paragraphs is a lot of writing, so don't leave this for the night before. Start working on it this weekend so that you can really, get some drafts done and really think about this in detail. Please shoot me an email if you've got any questions, or also you can send me a draft. Thanks.